The universe is vast, endless, filled with billions of stars and planets, but in the silent void, one world stands as a burning testament to the extremes of our solar system. A world so close to the sun that the very laws of nature seem to bend in its presence. Its surface is bathed in light and heat, yet it remains shrouded in mystery. This is Mercury, the smallest planet in our solar system, yet one of the most intriguing. Join us on an unforgettable journey to unravel the untold secrets of this scorching, frozen and enigmatic world. Mercury is a world of extremes. Sitting just 29 million miles from the Sun, it is the closest planet in our solar system, making it the hottest planet. But here's the twist, it's not the most habitable. Instead, it's a place where survival would be nearly impossible. To understand Mercury, we first need to understand its unique position in space. Mercury's orbit is fast, blazing through space at an astonishing speed of 112,000 miles per hour. To put that into perspective, that's more than twice as fast as Earth's orbit. And in just 88 Earth days, Mercury completes a full revolution around the Sun. That's almost a third of the time it takes Earth to orbit, but it has another strange characteristic. It rotates slowly. One full rotation on Mercury takes 59 Earth days, which means a day on Mercury is incredibly long. The day-night cycle on Mercury is so bizarre that a day on the planet lasts almost 2 years. Imagine experiencing a day that stretches for months, where the sun rises and sets in ways we could never expect. But what happens when a planet is so close to the sun? The answer: intense heat. So intense that on Mercury's surface the temperature reaches nearly 800 degrees Fahrenheit during the day. With its proximity to the sun, Mercury is scorched by radiation. This intense heat makes it a place where metals would melt and no living creature would survive the blistering sunlight. But it doesn't end there. Mercury's extreme temperatures are not constant. No, the real horror begins when the sun sets. On the dark side of Mercury, things take a sudden turn for the worse. With no atmosphere to trap heat, the temperature plummets. Nighttime temperatures can drop to minus 330 degrees Fahrenheit, colder than Antarctica at its most frigid. Imagine a world where the temperature can swing more than 1100 degrees Fahrenheit in just a matter of hours. This extreme temperature difference between a sweltering 800 degrees and a bone-chilling minus 330 degrees is one of Mercury's most defining features. A day on Mercury could send you from the frying pan straight into the freezer. Mercury's surface is a constant reminder of its violent past. Covered in craters, scars and valleys, the surface of Mercury is much like our moons. Frozen in time, an ancient landscape etched by impacts and lava. But there's one crater that stands above all others: the Caloris Basin. The Caloris Basin, one of the largest impact craters in the entire solar system. It measures nearly 960 miles in diameter, and it was formed by an asteroid collision that struck Mercury more than 3.8 billion years ago. The impact was so violent that it sent shockwaves across the planet, creating a strange, twisted terrain on the opposite side of the planet. The sheer scale of this impact is mind-boggling. The energy released was equivalent to billions of atomic bombs. Today, the Caloris Basin is a deep reminder of Mercury's tumultuous history, one that is still shaping its surface to this day. But what's even more surprising is the fact that Mercury's surface holds some astonishing surprises, like its massive cliffs known as Lobet Scarps. These cliffs, which stretch hundreds of miles long and rise more than a mile high, are the result of Mercury contracting as its interior cools. These giant cliffs are relics of a time when Mercury was more active, and they are proof that even the most stable planets can undergo massive changes over time. Mercury's core is a mystery in itself. The planet's outer shell is thin, about 1/6 the size of the entire planet, and most of Mercury's mass is concentrated in its core. In fact, Mercury's core is so large that it makes up about 85% of the planet's radius. To put it into perspective, Earth's core only takes up about 17% of its size. Scientists are still puzzled about why Mercury's core is so disproportionately large. One theory is that a massive impact in the distant past stripped away much of Mercury's outer layers, leaving the dense core exposed. Another theory suggests that the core might still be cooling, causing it to contract and shrink over time. Whatever the cause, Mercury's core has a strange effect on the planet's magnetic field. Despite having almost no atmosphere, Mercury has a magnetic field that's about 1% as strong as Earth's. This magnetic field, though weak, protects the planet from some of the sun's radiation. How could such a small planet maintain a magnetic field in the face of such extremes? The answer may lie in the planet's rapid rotation and the movement of molten material in its core. Mercury's magnetic field may be one of the greatest scientific mysteries waiting to be fully understood. It's hard to believe, but despite the extreme heat that scorches most of Mercury, the planet has ice hidden in the darkest, most inhospitable places on the planet. In the craters near Mercury's poles, where the sun never shines, ice has been found. These craters are permanently shadowed and incredibly cold. Even though Mercury is the hottest planet, the ice in these regions has remained frozen for billions of years. How is it possible that ice exists so close to the sun? The answer lies in the unique characteristics of these shadowed craters. Temperatures in these cold traps can remain at an unyielding -330 degrees Fahrenheit or -201 degrees Celsius, allowing ice to persist. This discovery has sent shockwaves through the scientific community, challenging everything we know about how the sun affects planets. Mercury, a world of extremes, surprises us once again. How can a planet so hot hide ice in its darkest corners? It's just another example of the strange, unpredictable nature of the solar system. For centuries, Mercury was a mystery. We could only see it from afar, and with our earliest telescopes, we could barely make out its features. But in 2004, NASA's Messenger spacecraft began its mission to unravel the planet's mysteries. For 7 years, Messenger orbited Mercury, sending back stunning images and data. The spacecraft revealed incredible insights into Mercury's surface, its magnetic field, its craters, and its strange interior. We learned that Mercury had once been much more geologically active than previously thought, with volcanic activity shaping parts of the surface. We also found evidence of ancient lava flows, as well as strange, bright patches of material that may hold clues to the planet's history. One of the greatest revelations from Messenger was the discovery of a faint but distinct atmosphere, a layer of atoms released from the planet's surface. This exosphere, made up of sodium, oxygen, and hydrogen, is so thin that it's barely detectable. It's a ghostly remnant of what Mercury might have once been. Messenger's findings helped scientists answer many questions about this enigmatic planet. But even after its final mission in 2015, we know Mercury is far from fully understood. Mercury's tale is one of survival against all odds. From its fiery surface to its frozen poles, from its violent past to its magnetic mystery, Mercury continues to captivate us with its extremes. But there's still so much more to learn. What more lies beneath its battered surface? Mercury may be a small world, but it is a giant in the world of mystery, a planet that forces us to rethink everything we know about our solar system. And as we venture farther into space, there's no doubt that the secrets of this burning, frozen world will continue to inspire awe and wonder for generations to come. Mercury might be the smallest planet in our solar system, but it's one of the most fascinating. And the more we learn, the more we realize just how much we still don't know. This is just the beginning of the adventure.